It's Professor Monty again. Let's talk about simplifying complex rational expressions by multiplying by the LCD. Okay, so remember, if I just have a fraction over a fraction, to do that, that's division. I can just change it to multiplication by inverting and multiplying and then multiply straight across. I will link that video to the end of this video in case you haven't seen that one yet. But this isn't a single fraction on top or bottom. I have terms. I have either addition or subtraction or both going on in either the numerator and or the denominator. So I can't just flip over the bottom. It's not a single fraction. So what I do is I look at all of these denominators. Now, this one doesn't show a denominator, so it's really 2x over 1. So I'm looking at all those denominators. I'm going to multiply the numerator and the denominator by the LCD of both of these individual denominators to cancel them out. So if I look at those 5, 3, 3, and 1, the LCD there is going to be 15. All right, that's the smallest number that all those numbers are going to evenly. So what I'm going to do is I'm going to multiply essentially by 15 over 15. I'm not building this denominator up to 15. I'm multiplying the whole numerator by 15. So here's what it looks like. So I've got the x over 5 minus x over 3. Down here I've got the 1 over 3 plus the 2x over 1. When I distribute in the 15s, it's going to look like this. This is going to get multiplied by 15. That's going to get multiplied by 15. And so are these. If it helps, write them as 15 over 1 to realize that, oh, this 15 is on the top, that 3 is on the bottom. 3 goes in there 5 times. This doesn't cancel here. 5 goes in there once, goes in there 3 times. 3 goes in there once, goes in there 5 times. All my individual denominators are gone. The 1 we don't have to care about because division by 1 doesn't change anything. But now what I have on top is 3 times x minus x times 5, 5x. And on the bottom, 5 times 1 is 5. 2x times 15 is 30x. On the top, these are like terms. I can combine it. 3x and 5x is 8x. 5 plus 30x on the bottom. I can't reduce past that because the 30x is a term. I can't cancel the term with something on the 8x. I can only cancel factors. That's my answer. But in one step, I essentially get rid of the individual fractions. So let me show you. If you don't care about losing the original problem, you can look at this and look at all these denominators. Oh, I've got an x squared, an x, and an x to the third. My LCD in this case is x to the third. It's the highest power of x. I'm going to multiply top and bottom by x, distribute it in, so everybody gets an x to the third, my LCD. So an x to the third here, an x to the third here, and here, and here. Well, those two cancel 2 of these. I get 1 left. This one cancels out 1 of those. I still have 2. This one cancels out 1. I still have 2. And these 3 all cancel out. All the individual denominators are gone. All I have left on the top, 7 times x, 7x, 2 times x squared. And then on the bottom, I have 6 times x squared minus 3. Now remember, I can't cancel terms. I can only cancel factors. So I can factor that up to see if anything cancels out. It doesn't look like anything will. But notice in one step, I went from a complex fraction just to a regular fraction. On top, I say I can factor out an x, so maybe I'll do that, and I get 7 plus 2x. On the bottom, I can factor out a 3. I get 2x squared minus 1. Well, these clearly don't cancel out. The x and the 3 don't cancel out. There's nothing common there. So that's as far as I can go. That's fully factored. Some books will put the answer this way as well because nothing does factor. I like it factored out so that I can check to see if it cancels or not, reduces. But you'll see one or both ways in the back of the book sometimes. Be specific with your instructor to see what they're looking for. And obviously on the exam, answer it the way they want you to answer it. Okay. But if you have terms in either the top or the bottom, especially the bottom, you're going to want to multiply each piece by the LCD and then cancel out, get rid of your complex fraction immediately, and then multiply through, simplify, get to your answer.